Hello, everyone. I'm Joel Hurt. I know that because it says it on my badge. I'm walking out here with a roll of tape, and you're probably saying, what the heck is this guy doing with a roll of tape? I like to speak with props, and this is the only thing I found backstage. But I was in Barcelona a few years ago speaking about opportunities, and I used castanets on stage. And 3 years after speaking, I met a guy from Sydney. He said, "You're that crazy guy that was on stage with castanets." So hopefully you'll remember who I am. And once again, I'm Joel Hurt. This is me, Vice President of Industrial Plant Solutions for US and Canada. I start to talk fast sometimes, so forgive me. I'll try to slow down. 20 years of engineering experience with Bechtel, Raytheon, Jacobs, and in between the 20 years I've done with Leica Geosystems, I did a little bit of my own out there, doing some things on my own. I worked a little bit with Bentley Systems. So actually, please do not add up the years because you'll say, where the hell is your walker? Technology, we're gonna talk a little bit about technology, right? Water wheel. This is what technology was like some time ago. Wait a minute, was there anyone around when that first started up? Good, because I would have to talk very loud if you were. But technology has changed, right? And it's continued to change. A lot of people have seen this picture, very iconic picture, and I like to show it, and I like to point out some things. And it talks about how technology and how we're changing moving forward. No hard hat. You won't find that anymore. You can't go on site without a hard hat. This guy is smoking, right? You can't do that. We are changing, we're evolving, we're being much more safer, we're doing things in a much better way. Here's a guy drinking. Here's a bottle, right? He's drinking. No, you wouldn't want anyone on a site where a site can be dangerous and actually drinking. And these two here, I don't know what they're firing up, okay? Maybe in California or Colorado, some other states it's okay, but that's something we don't do, right? So innovation and change is happening, and this is something that we are looking at and talking about today. I'm going to move around a lot because I don't like to stand in one place, and I know it drives the camera people crazy, but I'm going to move around. But the future of manufacturing, right? It has changed. Manufacturing is no longer simply about making physical products, right? Changes in consumer demand, the nature of products, the economics of production, and the economics of the supply chain has led to a fundamental shift in the way companies do business. I think that's very true because that's why we're here today. We're here to look at what we can do and how we can affect change in our business. Additionally, we have accessibility to actionable data. This is really key, right? Looking at what we can do with that data to affect change in how we do manufacturing, to reduce costs, risk, and to escalate innovative thinking and safety. I think safety is very important and something that we always should talk about, particularly in dangerous environments, right? Safety is paramount, and we have to have safety in everything we do. But all this has brought about this digital transformation, right? We are moving into a digital world. We're actually in a digital world right now. So digital reality solutions for the complex life cycle of a complete industrial plant is very key. And some people refer to it as the digital twin, right? So we can take this information, we can begin to work with it, we can have conceptual design, we can do designs with this information, construct, operate, maintain. We can do all of that with this information in a very economical and very smart way. And that makes us much more efficient in what we're trying to do. But we're supposed to be talking about reliability through innovation, 3D laser scanning. So I'm going to talk about 3D laser scanning. When I brought this topic up, I was told, well, you might have some in the audience that don't know what it is. Some who may. So if you already know what this is, forgive me, but I'll talk a little bit about how it works and what it is, and then we'll talk about how it actually relates to EAM. So 3D laser scanning is also called reality capture sometimes. Some of you may have seen the presentation yesterday by CAD Services, really great presentation about how they're taking 3D laser scanning and adding it into EAM. These are some of the instruments that are used. These on the tripods are called static. The one that in the middle here, that's called an RTC. It's across the street. If you want to see it, you can just walk over and take a look at it. The one kind of raised up in the air is a handheld. Then there's a quadruped, a robot. You can actually put them on robots and have autonomous, and we'll talk about that some more. And then we have a flying drone where you can actually fly and capture it. Now, the way laser scanning works is it emits light. So we know the speed of light, so we can actually time how much time it takes to go from point A to point B and back to point A. And we build what's called a point cloud. And that point cloud represents a 3D model. So I'm sorry once again if this is something you already know, but just trying to educate everyone. So laser scanning is technology that uses laser beams, as I just mentioned, to rapidly and more accurately measure distances to surfaces. This is what it looks like. On the left is an actual facility, and to the right is what the results from a laser scan looks like. Now, it's kind of funny colors. You can have actual true color. You can have this, which is laser intensity, or you can have it in black and white. Now, the reason it has this weird kind of oranges, red color is that's the amount of light coming back to the instrument. Laser is nothing but a light, so lighter colors reflect light, darker colors absorb light, so it depends on how much light is coming back to the instrument. So if I'm talking fast again, I better slow down. Did you know, I got a couple of these, did you know, that people gain 75% of their knowledge from visual images? 75% of what you learn comes from visual images. This is important because laser scanning is very visual. It allows you to see your facility as you know it. And that's why employers and governments, everywhere you go, have signs. You can look around and there's signs in this building. You cannot leave this building without seeing a sign. You cannot get home without seeing a sign. And just so you know, 13% is from hearing and 12% is from smell. And the smell, I can tell you where not to go for dinner, where I went last night. Hearing, hopefully what you're hearing, you'll get some of this, so maybe I should do something crazy up here so you can see sight and hear me at the same time. But this type of technology, 3D laser scanning, brings that point home. So what I wanted to do was share some statistics that I found that talks about laser scanning so that it's not just me saying, hey, laser scanning is pretty cool. But widespread use of digital technologies could decrease production costs between 10% and 20%. That's huge. That's a huge number. 58% of oil and gas executives said COVID pandemic has made investing in digital technology more urgent. I think everyone is seeing that. And the same thing, 87% of oil and gas CIOs expected their digital programs to increase or stay the same. So this type of technology is something that we're going to see, and we need to understand how we can build our EAM and reliability into a digital asset. So what does this give you when you have this digital asset? Accessibility, right? You have the ability to access this data and look at it. Karen walks past this pump every day. Now, if she can see that pump when she's trying to access the data about the pump, it becomes very easy. I know this area. I work in this area every day. Data accuracy. The data is very accurate. Laser scanning gives you right around 1/8 of an inch accuracy. So it's very accurate, so you can actually design with it besides just looking at it to understand the asset. Measured, you can measure this. I mean, you can go in and you can measure any point within this from your phone, from your tablet, from your laptop. It doesn't matter. You can have access if you're granted access to it. A very fast turnaround. This is important, right? Because you need to have this data quick. You want to have it in front of you so you can start to make intelligent decisions. The unit that we have across the street, the RTC, I can sit it here, and in 28 seconds, it can capture everything in here. In 28 seconds, I can capture everything in here, and then we can start to look at those assets and understand what's on the floor. That's pretty fast. And safety. You've heard me mention safety before. I think safety is really, really important. I don't want to go in a plant, or I don't want to go into a manufacturing facility where safety is not important. Many facilities I go to, I actually have to give a safety tip before we actually start the meeting. That's how important I find it. And laser scanning can do something that you shouldn't have to do, which is climb a ladder to understand an asset. You can have the laser scanner on the ground and it can capture the information above. There's scanners that can see a kilometer to give you information a kilometer away. We have robotics that you can send robotics in. So really cool things to do to maintain safety. Some more stats here. This is from Deloitte. I think everyone knows Deloitte and what they read. But safety and sustainability, you can have a 10% growth from a smart factory. And smart factories, I believe, play into this laser scanning aspect. Asset efficiency, 20%, product quality, 30%, and a 30% reduction in cost. I think every manager, every VP, every president, every plant manager are interested in these 4 items. They definitely want to look and see what can we do to achieve these numbers. So reality capture. I'm clicking. Okay, yeah. The real world isn't perfect, right? We all know that. And reality capture gives you the real world. My CAD friends may not like this, you know, they might want to plug their ears, but in a CAD world, everything is orthogonal. Everything is straight, everything is pretty, everything is perfect. When you walk out into your facility, everything is not perfect. There's going to be sags and pipes. These are things that you want to know, things you want to find out about. So you can begin to do some type of understanding and maintenance of it. You can capture at high speed, I mentioned it, 28 seconds, we can actually capture everything around you. Or you can create as you walk. This unit, as you just walk around, is capturing your information very quickly so you can start to understand the assets that are on site. Capturing autonomously. I want to talk about that for just a bit. So I'll let this get started and I will walk through it and talk about it just a bit here. So this is a quadruped, a 4-legged robot. This particular one is by Boston Dynamics, and it has a Leica BLK arc on top of it. And we can put other scanners on top of it as well. What's really cool about this is that you can send this into the facility at any time. There are companies that have it start up at night, and it walks around at night and gathers information on the facility, things that have changed, things that are in place, and then comes back, docks itself, downloads the information, and then when you come in the morning, you can start to understand what's happening in the facility. This one goes upstairs. It can do a number of things. Ford has one, and they had to change the name from Spot, because typically they're called Spot. Ford changed theirs to Fluffy because they wanted to begin with an F, a Ford Fluffy. But this is the resulting data, right? So this is what the data looks like, and now you can actually start to see what's in my facility, and you can start to tag that information with your EAM back office stuff, and now you have a really compelling visual view into your facility. There's 3 things data reliability relies on. It has to be complete, accurate, and consistent. And I think that laser scanning facilitates that. I mean, it really gives it to you in ACES. So if you look at completeness, it captures everything physically in the facility that can be seen. It's a line of sight device, which means it can only capture what it sees. So you may have to do multiple scans. So what does that mean? If I'm scanning here and I want to see the back of that prompter, I have to move the scanner around, and the scanner will tie all that information together. The thing is that it is absolutely complete, it's immutable, and it is really rock solid, really cool. Accurate, it provides a complete point cloud, which I mentioned earlier, 1/8 of an inch, is true to world. If there's a sag, you can understand there's a sag in a pipe. I need to place a hanger on that pipe, or a shoe or a guide or something to help me understand what's there. If you have equipment that you have to remove and get back in, you can do planning. You cannot do that in a CAD model, unfortunately, because it's not real world. A plant changes over time. There's things going to be added. this thing's going to be removed. You cannot take a CAD model and understand where a field routing pipe was and things like that. And consistent. It is consistent. It's very consistent. It does the first two remarkably well, and it can be available to anyone at any time. It's funny. I was sitting on the beach on Waikiki, and I got a call from a customer, and I actually took my phone out, started working on it, looking at the model. My wife slapped me in the back of my head, and I put my phone down. But the point is, you can actually access this from anywhere. So capture every detail of the facility without affecting production. Think about it. I don't have to shut down. I can capture this. Solve problems before they occur. Like I mentioned, you can understand piping. You can understand things that are actually moving and changing. You can start to do that before these problems actually occur. Plan and protect with actionable information. This is where I'm talking about tying it into your EAM, and I'm going to get to some more of that. And manage it digitally from anywhere. So, would you play this video? In this particular video, we're inside of a plant. The yellow diamonds are scan locations. The red are points of interest. So, in these global tags, we can click on this, and we can pull up the tag that's associated with that pump. We're tying it back in. How about that? You can associate the website of that POW pump, and you can go to their website. You can start to tie in this metadata. This is where I'm talking about tying in that data. You saw the spec sheet. You can tie the spec sheet in. You can tie the PNID in. You can tie in any information you want that's in your system to it graphically. And now you can begin to see it and understand it in a very, very meaningful way. So laser scan data is essential. It is key to sharing reliable data for decision makers. You really want decision makers looking at this and understanding what we're doing and tying this back in. I'm speaking fast once again, I know, but I have 168 slides. No, I'm just kidding, I wouldn't do that to you. Performance optimization, simulation of what if scenarios. You saw that earlier if you were in here in the CERN, where they were showing how to evacuate in a radiation situation. You can start to build that information in there. Digital remote management. You know, COVID taught us a lot, right? And one of the things was, I can't get into my facility. Man, what's really going on? If you had this digitally captured, you could do that. Predictive and preventive maintenance. I spoke a little bit about that in virtual training. Virtual training is cool. It's really important in understanding what you can do with virtual training. Hey, I said there'll be another did you know. Did you know 78 million baby boomers are expected to retire over the next 10 to 15 years? That's a lot of people leaving the workforce and a lot of knowledge walking out the door. Having EAM and having this information tied to you graphically, you now have a graphical interface into your data. Think about it. How powerful would that be? I can sit down and I can pull up and say, I need to look at aisle 146. What's in aisle 146? It pops up all the information and it's graphically. And you don't have to go out there. If you're in a dangerous environment, OSHA really don't want you in the plant. They would rather have you sitting somewhere else. But this allows you to look at the information before you have to go into the plant, thus reducing man hours in the plant and equaling safer man hours. Having a visual record of the facility helps less experienced employees learn the job and the facility quicker and safer. Yeah, COVID has shown the virtual remote access to your facility is advantageous, right? Having that ability to look at what you need, start to tie those records back in is really huge. Risk mitigation. And yes, that's a Kansas City helmet on there. Are there any Chiefs fan? I just moved to Texas from San Francisco, so I'm still a 49er fan, so I don't like the Chiefs. But precise digital records, you can have that. You can have your records, your information. You can have all that tied in very neatly, very compactly. There's no better way, and this is from a customer, to achieve regulatory compliance and operational value than with digital asset management based on reality. Based on reality. That's what we're going to give you, that's what we're going to ask you to work with, is reality. Pretty simple. How about another video? I think you guys need another video.
Is a digital reality solutions company unleashing the power of autonomy to measure and improve what industry needs most. Productivity, efficiency, quality, lower cost, less waste. We believe that industry can save our world, that it can be the solution instead of the problem, and that global commerce is the path to a sustainable planet. Hexagon is intent on making this a reality by putting data to work autonomously to measure progress and improve outcomes. Our technologies digitally capture and measure all things in all places. They position, track, and navigate anything. They dimensionally design whatever you want to create, from facilities to evacuation plans. Simulate billions of real-world scenarios. Deliver location intelligence about anything, anywhere. Together, these technologies fuse the physical world with the digital. They empower us to make that giant leap beyond automation to autonomous. Because autonomy is data doing its best work. Yes, it will drive our cars, yet it will do so much more. It will carefully protect our citizens and nations, operate complex assets and facilities reliably, accurately construct buildings and infrastructure, manufacture products and goods intelligently, responsibly produce from our mines to our farms. Data will do all of these things autonomously. When industry embraces this, sustainable outcomes will follow. Hexagon.
Autonomous, sustainable future. It's definitely what we're about. That's what we're talking about. That's something that we believe in, we walk in every day at Hexagon Leica. And it's something that we believe that laser scanning can do for you. I mean, you look at this is a fuzzy image, you know, what the heck is it? This is what I think laser scanning can do. It can bring it all into focus. Laser scanning really loves this type of stuff because there's a lot of geometry, and it really loves geometry. It eats that up, and people look at this and, you know, wow, I'm not really understanding. But as you start to tie in all your metadata to this information, to the scan data, you can then actually really reap great benefits. So, kind of in summary, innovation has been the agent for change and a force multiplier in driving events globally for centuries. This is really true. I believe that innovation and technology has been the thing that pushed civilization along for years. I mean, from a stone to a water wheel into today. Decisional reliability is something that we can give you also. It has been said that reliable data must have three components: completeness, accuracy, and must be consistent. Those are things we can give you. Capture easily, manage facility, manage data remotely, reducing risk by providing precise digital records. These are all things that you can get with the laser scanning, and tying in your actual metadata with it is very powerful. Kind of closing up here, we do a lot with STEM. I hope you guys do. If you are associated with STEM facilities or working with kids and students, remember they are our future, If you'd like for us to come out and talk about lasers and laser technology, let me know. Happy to come out and talk to students with you in your STEM effort. And that pretty much does it. You did not come to Streamline to feel the future. You came to shape it. And if nothing else, I'd like to leave with this. Sometimes you just have to pick yourself up and carry on. Thank you.
Fantastic. Thank you, Joel. What a just mind-blowing presentation for me. Maybe I'm a simpleton, but I love everything that you're doing. I do have one question asked by Marcel Van Wingerden. It mentioned that you zoomed in on a label in the previous or earlier in your slide. Was that included in the scan, or was that a separate attachment?
No, it's included in the scan, but we can do separate attachments as well. What you can do, if you're familiar with laser scanning and with our technology, while you're scanning, you can take a tablet or a phone and take a picture of something that is an item of interest, and it would automatically and immediately tie it back to that scan location so you know where you are.
Fantastic, thank you. That is all the questions I have through the app. I'll give a few moments for anybody in the audience that wants to ask a question that did not get through the app.
Yes?
Are there capabilities for change detection in the native technology?
Yes, there's if you do a scan on Monday and you come back and do a scan on Wednesday, right? There's a change mode. You can understand what has changed and you can identify it. I don't want to get too deep, but there's some other things that you can do in it. You can actually integrate it with your CAD model. So you have a hybrid where you have the actual scan of the real world and what was supposed to be delivered or designed or built. And now you can have that hybrid. If you're looking to do improvements and you need to understand where can I route ducking, it will give you interference detection. It'll tell you things like that before you actually start to save you costs there.
Fantastic. Any others?
You get to go to lunch early. Thank you for your time.
Yes, thank you, Joel, again.